Have you ever pondered how old the planets in our solar system might be? This cosmic conundrum is no easy puzzle to solve. Our universe keeps its secrets well, but with a little scientific detective work, we can begin to piece together a timeline of our solar system. The concept of estimating the ages of planets can seem as vast and nebulous as space itself. To tackle this, scientists employ a variety of methods. One of the most reliable techniques is radiometric dating, a process that allows us to estimate the age of rocks by studying the decay of radioactive isotopes within them. Another method involves studying rock samples from meteorites, the fallen fragments of asteroids and comets. These celestial remnants can provide invaluable clues about the age and history of the planets. With these tools in hand, we can set out to uncover the history of our celestial neighbors. So let's dive into the history of our celestial neighbors, shall we? To understand the age of our planets, we first have to travel back to the birth of our solar system. Our journey begins around 4.6 billion years ago, with a giant rotating cloud of gas and dust. This is known as the nebular hypothesis, the leading explanation for the formation of our solar system. Picture a celestial cloud, vast and diffuse, swirling in the infinite expanse of space. This nebula, composed primarily of hydrogen and helium, along with dust and other heavier elements, is the cradle of our solar system. As the nebula collapsed under its own gravity, a process that took several million years, the center grew hotter and denser, eventually igniting to form our sun. This collapse also set the nebula spinning faster, causing it to flatten into a disk. This spinning disk, the protoplanetary disk, is where the magic happened. The dust particles within the disk began to collide and stick together, forming planetesimals, the building blocks of planets. These planetesimals continued to collide and merge, growing in size, eventually forming protoplanets. Over time, these protoplanets swept up more and more of the surrounding material, becoming larger and larger. In the inner part of the disk, closer to the sun, the planets formed were rocky due to the high temperatures vaporizing lighter materials. These include our terrestrial planets: Mercury, Venus, Earth, and Mars. In the outer part of the disk, where it was cooler, the planets could retain lighter gases such as hydrogen and helium. These are our gas giants: Jupiter, Saturn, Uranus, and Neptune. It's a process of cosmic construction that took around 100 million years. That's a blink of an eye in the cosmic timescale. But it set the stage for the development of life, at least as we know it, on one of these planets. With this cosmic cradle in mind, we can start to explore the formation of individual planets. First up, we have the terrestrial planets, the innermost planets in our solar system. These planets, Mercury, Venus, Earth, and Mars, are the smaller, denser siblings in our celestial family. They're all made primarily of rock and metal, hence their classification as terrestrial. Let's begin with Mercury, the smallest planet and the one closest to the Sun. Like the rest of the terrestrial planets, Mercury was born from the remnants of the solar nebula, a vast cloud of gas and dust left over from the birth of the Sun. This process, known as accretion, began around 4.6 billion years ago. Next, we have Venus, Earth's twisted sister. Venus shares many similarities with Earth, including its size, composition, and proximity to the Sun. It too was formed from the solar nebula's remnants around 4.6 billion years ago. But its evolution took a drastically different path, leading to its current inhospitable state. Then we come to our home, Earth, the only planet known to support life. Earth's formation and evolution have been shaped by a myriad of complex processes, including the formation of its atmosphere and the development of life. But like its terrestrial siblings, Earth's age is also estimated to be around 4.6 billion years. Finally, we reach Mars, the red planet. Mars is half the size of Earth, but shares many geological features with our home, including the largest volcano and the deepest canyon in the solar system. Mars also formed from the solar nebula's remnants around 4.6 billion years ago. So all these terrestrial planets, Mercury, Venus, Earth, and Mars, were formed from the same material around the same time, giving them a similar age of about 4.6 billion years. They are testimony to the marvel of celestial birth and evolution, each with their unique twists and turns. But what about the outer planets? Are they as old as their inner counterparts? Let's continue our journey to find out. Now we journey to the outer edges of our solar system, where the gas giants reside. In this distant realm of extreme cold and darkness, the planets Jupiter, Saturn, Uranus, and Neptune hold court. These colossal bodies, primarily composed of hydrogen and helium, are the elder statesmen of our cosmic neighborhood, having formed about 4.6 billion years ago. Jupiter, the largest planet in our solar system, was likely the first to form. Its massive size allowed it to quickly gather up gas and dust from the surrounding solar nebula. As a result, it's possible that Jupiter is slightly older than its sibling planets. Saturn, the ringed beauty, wasn't far behind. Its formation was a similar process to Jupiter's, amassing material from the solar nebula to grow into the second largest planet. However, its greater distance from the Sun meant it may have formed just a bit later than Jupiter. Next in line is Uranus, the tilted giant. It's believed that its unique axial tilt, which causes it to spin on its side, was the result of a violent collision early in its history. This event didn't significantly affect its age, but it offers a fascinating glimpse into the sometimes chaotic early days of our solar system. Finally, we reach Neptune, the furthest planet from the Sun. Neptune's formation was a slow and steady process, its distance from the Sun meaning it took longer to gather the necessary materials. As a result, it's likely the youngest of these outer planets, though only by a relatively small margin. Despite these minor differences, all four gas giants share a common origin and a similar age, around 4.6 billion years old. Their formation from the same solar nebula ties them together in a cosmic brotherhood, each one a testament to the enduring lifespan of our solar system. So, as we can see, the age of our planets is a testament to the longevity of our solar system. Now that we've taken a tour of our solar system, how do the ages of our planets compare? The age of our planets is a fascinating subject, and one that ties all of them together in a cosmic bond of unity. The grand old dame of our solar system, Mother Sun, first ignited her nuclear furnace some 4.6 billion years ago. As she took her first breath, sending out waves of heat and light, her gravitational pull began to shape the cosmic dust and gas swirling around her into the planets we know today. Let's put this into perspective. If we were to scale the age of the Earth down to a single year, each day would represent roughly 12 million years. That means our solar system was born around January 1st, and life as we know it didn't emerge until around the end of November. Despite their diverse appearances and environments, all our planets share a common birth date. They were all formed from the same interstellar nursery, a swirling cloud of gas and dust around the same time. This common age is a testament to the unity and interconnectedness of our solar system. When we look at Mercury, the smallest planet, we see a world that has aged gracefully, its surface scarred by billions of years of meteor impacts. Venus, our sister planet, has also endured the passage of time, its thick atmosphere trapping heat and creating a surface hot enough to melt lead. The gas giants, Jupiter and Saturn, are old souls, their atmospheres whipped into colorful bands by centuries of storms. The ice giants, Uranus and Neptune, have also weathered the cosmic storm, their icy surfaces a testament to the frigid outer reaches of our solar system. Each planet's age and unique characteristics provide us with precious insights into the history and evolution of our solar system. They are like time capsules, each holding a piece of our cosmic history. Remember, each planet in our solar system holds a piece of our cosmic history, a testament to the vast expanse of time. It's been quite a cosmic journey, hasn't it? We've traversed the birth of our solar system, ventured through the terrestrial planets, Mercury, Venus, Earth and Mars, and journeyed amongst the gas giants, Jupiter, Saturn, Uranus and Neptune. Each step of the way, we unraveled the ages of these celestial bodies, an endeavor not without its complexities. We've learned that our youngest planet, Mars, is a mere 4 billion years old, while the elder statesman of our system, Jupiter, boasts an impressive age of over 4.5 billion years. To uncover these ages, we delved into the fascinating world of planetary science, utilizing methods such as radiometric dating and crater counting. We found that understanding the ages of our planets not only gives us insight into our solar system's history, but also into the processes that have shaped it. Next time you look up at the night sky, remember, You're not just seeing stars, but a glimpse into our solar system's ancient past.